So we've already looked at units that are used for specific measurements. What we're going to be looking at in this lesson are prefixes. Now, prefixes are attached to a unit and can increase or decrease its size. So if you look, for example, at all of the prefixes that are above the base unit, all of those prefixes make it larger than it was before. So for example, kilo. 1 kilo base unit, so let's say the base unit is meters, 1 kilometer equals, or kilometer equals 1,000 meters. So by putting kilo in front of meter, you increased it by 1,000. You multiplied that one by 1,000. For mega, 1 mega, let's say for example the base unit is liter, 1 megaliter equals 1,000,000 liters. So all of those prefixes above the base unit make that unit larger, while all of the prefixes below the base unit make it smaller. So for example, deci, if you have a decimeter, 10 decimeters equals 1 meter. So you effectively took the meter and decreased its size. One that's more familiar to you guys would be, for example, centimeter. There are 100 centimeters in a meter. Or for this class, milli. There are 1,000 milliliters in 1 liter. So you guys need to be comfortable with these prefixes because you're going to be using them quite a bit. So I'm going to ask that you guys memorize these values. And a good way of memorizing them is keeping in mind that the prefixes that are above the base unit make it larger. Therefore, the relationship, the power of 10 that it's multiplied by, is in front of your base unit, so meters, seconds, or liters, while for the prefixes below the base unit, that power of 10 goes in front of the prefix. So we're going to be converting quite a bit, and so the first time we convert, we're going to be doing it with prefixes. Now, there is a simpler way of converting between different units. However, I want you guys to get used to the technique that we're going to be using throughout this class. So if I give you 14.2 decameters and I want you to convert it to meters, you're going to follow these 5 steps. The first thing you're going to do is you're going to write your given, which is 14.2 decameters. Then you're going to crisscross swoosh, which is a multiplication sign and then a line. And you're going to write the unit that needs to be canceled in the denominator. So I'm going to crisscross, swoosh with that line, and I'm going to put decameters on bottom because I'm trying to get rid of that unit. Then I'm going to put the unit I want to get into up top, which is meters. And then I need to write the conversion factor. Well, there are 10 meters in 1 decameter. And so I'm going to just end up multiplying 14.2 by 10, and that gives me 142 meters, and that's all there is to it. The last concept for this lesson is density. Now, density helps us to relate mass and volume, and the important thing about density is that it can be used to identify substances because every substance has a unique density. So the mathematical equation for density is density equals mass divided by volume. So let's look at an example really quickly. It tells me that the mass of a sample is 562 grams, its volume is 14 milliliters, and it asks for the density. Well, density equals, the mass is 562 grams, and the volume is 14 milliliters. And so when I divide, I end up getting 40.143. Well, here's your first opportunity to round based on decimal place. This is your first opportunity to round your final answer. Well, since my final step is dividing, I'm going to be rounding based on significant figures. So 562 has 3 significant figures, 14 has 2 significant figures, so my final answer needs 2. Well, 40, and that's it, it would only have 1 sig fig because I'd be counting from right to left. So the question is, how do I get it so that I'm counting left to right to be able to count that 0? Well, if I add a decimal, 40 point, then that would be 2 sig figs. And so my final answer is going to be 40 grams per mil.